So the learning goal for this video is we want to understand what a complex number is. And so we have to start off with kind of setting the stage, and then we're going to get into a definition of what a complex number is. So the first thing we're going to wonder is, what is the square root of negative 16? And before this video, the answer that you always gave when you got the square root of a negative anything was there is no solution. We can't do that. And so I'm sorry to say, but your teachers have been lying to you all these years, or we have been withholding the truth until today, and now we're going to explain that you actually can do something with the square root of negative 16. All right, and to do that, we're going to actually have to go a little bit further, and we need to introduce a new number that you've never heard of, and that number is called I. Okay, so the imaginary unit I is defined as the number whose square is negative 1. Okay, so we have to talk about this idea of I. I is not a variable. I actually stands for a number, so it's more like pi, right? If we have that symbol pi, we know that it means 3.14. When we talk about I, we're saying the square root of negative 1. Okay, so this is what we mean. Whenever you see the imaginary unit I, what we mean is the square root of negative 1. And that means that anywhere that we see the square root of negative 1 show up in a problem, we can make it go away, and in its place we can substitute I. Okay, so we're going to look at some examples and see how this happens. Okay, so if I looked at problem number 1 here and I said, what is the square root of negative 81? Before today, we would have said, you can't do that. We're going to stop the problem right here. Now we can do something with it, because what we're going to do is we're going to split negative 81 up into two parts. And we're going to say this can be split up into the square root of 81 and the square root of negative 1. And the reason why is because I can do the square root of 81. The square root of 81 is 9. Okay? I can't do the square root of negative 1, but I can say, well, I can replace the square root of negative 1 with an I. So I'm going to call the square root of negative 81 9I. Okay? 9 times the square root of negative 1, and that's the best I can do. So we're going to be able to simplify these negative radicals. Before we couldn't, now we can. Okay? So let's take a look at a couple more. The square root of negative 17, again, same idea. I'm going to say the square root of 17 and the square root of negative 1. Okay? So if I looked at this one, I would say, well, I can't do anything with the square root of 17. I'm not going to take the square root because I want it to leave it in radical form. So I can't break down 17 at all. So this is done. I can't do anything with this. I can replace the square root of negative 1 with I. So again, I'm going to go to the problem and I'm going to say, just leave the square root of 17 alone. And whenever I have a number, I don't usually place it on the right-hand side. Usually we'll put it before the radical. So I'm going to put the I, this piece, just out in front. So I would say I square root of 17 is the simplified version of the square root of negative 17. Right? So in all these problems, we're just breaking out a negative 1 and simplifying the remaining radical. Okay, so problem number 3, got a little bit more work to do. Problem number 3, we're going to say, okay, let me break it out. Square root of 12 and the square root of negative 1. But hold on a second. The square root of 12 back in Algebra 1, we could do more with this. We could break this down again because there's a perfect square in this. So you still have to do that. Square root of 4, square root of 3, and I'll leave that square root of negative 1 as well. So the reason I like this is because now there's two parts of this that simplify. Square root of 4, I know what that is. It's 2. The square root of negative 1, we know what that is. Up here we said anytime you see the square root of negative 1, you can replace it with I. Square root of 3, this one right here in the middle, I can't do anything with that. It was kind of like the 17 over here. So I'm going to leave that one alone, and I'm going to say, let's leave it as a square root of 3. And I would say this expression, 2I square root of 3, is the simplified version of the square root of negative 21. Or I'm sorry, square root of negative 12. One more problem to just get the idea of this, and we're going to move on from there. So 3 square root of negative 24, I'm going to break up. I'm going to say 3, okay, the square root of 24, and the square root of negative 1. Well, the square root of 24 I can simplify again because it's got a 4 in it. So I'm going to say 3 square root of 4, square root of 6, square root of negative 1. Right? So I just took the square root of 4 and square root of 6. That came from the square root of 24. This is really saying 3 times the square root of 4. Well, the square root of 4 is 2. This is really saying 3 times 2, and that's 6. The square root of negative 1 is I. And then this little piece here, the square root of 6 in the middle there, I couldn't do anything with that. So that's going to stay underneath the radical, and I would say this is the simplified version of the square root of 3 square root of negative 24, 6I square root of 6. Okay, so there are some problems here for you to try. You can pause the video, try out these problems, and make sure you have a good handle on how to simplify radicals. Alright, so let's talk about an imaginary number. So here's what an imaginary number is. The imaginary number is going to be uh, made up of two parts. So the imaginary part can have an I attached to it, and we're going to have a real number part. So let me give you an example of something that this would look like. I can place any real number I want. Remember, real numbers are numbers that could be fractions, they could be decimals, they could be radicals, they could be whole numbers, they could be negative numbers, anything we want. So let's say, for example, let's make it simple and say I'm going to put a 6 here. Okay, I can make this plus or minus. We'll go with plus. Okay, the b value is going to be also a number. Like let's say, for example, 4. Okay, and then I is going to be attached to the 4. So the imaginary part is always going to be a number, or maybe there won't be a number. Maybe it'll be like 1 or something like that. And it's always going to be attached to the I. This is the imaginary part of, and I'm going to change the name of this. Let's call it a complex number. Okay, an imaginary number is the I part of it, but the entire expression, I like the phrase complex number better. So it's going to be made up of a number that does not have I attached to it and a number that does have I attached to it. Okay, but here's the weird thing about this. Technically, numbers that are whole numbers, regular old numbers like, for example, 5, this is technically a complex number because I can write this as 5 plus 0i. So technically, 5 is a complex number. And these pure imaginary numbers are ones that don't have a real number part to them. So again, I can say 0 plus 14i. Well, that's just 14i. I don't see a real number part, so I can say that's really a pure imaginary number. Okay, so we're going to go a little bit deeper into this idea of imaginary and complex numbers. We're going to graph them. We're going to multiply and divide them, add them, or subtract them. We have basically this whole new set of numbers. It's kind of like how we started off with just whole numbers, and then slowly said, well, wait, there's not just whole numbers, there's also fractions. So when you learned about fractions, you had to learn how to add and subtract and multiply and divide and do all the stuff that you did with regular numbers, you had to learn how to do with fractions as well. So now that we have this new set of numbers, we're going to do the same thing. We're going to say, now that we know about complex numbers, how do you add, subtract, multiply, divide, solve, all that stuff that we did with regular numbers? How do we do that with complex numbers now? And so the next video is going to focus on how do you graph them? And then we're going to focus on how do you take their absolute value, and they're going to continue from there. But for right now, here's what you need to know. A complex number is any number that can be written as a plus bi, and that imaginary number I stands for the square root of -1. So we can simplify any radical now. Even if it has a negative number under it, we can still simplify it, and it'll just contain an I.